All right, last video we did some work on Doppler shifts, so let's do some more practice with that type of stuff and see if we can incorporate some other things as well, but we'll just start some basic Doppler shifts. So let's see, maybe, all right, so maybe we got some grass here, something like that. Let's draw a tree over here. Here's my nice tree. Okay, unfortunately the tree happens to be on fire. There we go, draw some fire in there. Alright, so there's some fire, there's some smoke coming out of it. Okay, alright, so then we've got the fire truck coming. So the fire truck saw the fire, saw the smoke, and they're coming to the rescue here. So there's the fire truck, something like this. Actually looks like a really, really small fire truck, but that's okay. And a ladder on the side. Alright, so there's the fire truck. Of course, the fire truck's got a siren on it. So there's sirens blaring, and let's say the siren's blaring at 7,400 hertz. And here's a little woodland creature, maybe a little squirrel or something like that. So there's my little squirrel, a little tail sticking up. There we go, something like this. Okay, so here comes our fire truck, and our fire truck is coming in at 25 meters per second. So what frequency does the squirrel hear from the siren? Okay, well, let's do some practice here. So Doppler shift, so frequency primed is frequency 1. This is the expression we had last time. Plus or minus, well, truck is getting closer. So the waves are going to get squished together, so this will be a higher frequency. So I'm going to add those together. All right, so my frequency, of course, the first frequency would be the 7,400 hertz. The V would just be the 25 meters per second, and speed of sound, we've been typically using 340, so we can use that again. So we'll do the 25 divided by the 340, add that to the 1, and then find out the new frequency. Okay, so punched out, let's see, we got around 7,944 hertz, something like that. So that's the frequency the little squirrel would hear as the fire truck is getting closer. Okay, and of course if it was going away, we would subtract instead of add. Okay, let's try something else. Let's get rid of that. Okay, let's try something else. Let's try this. Let's suppose, we got like a ski hill or something like that. Or we got a ski hill. There we go, something like that. Okay, and here you are. Let's see, let's give you some skis here. So some nice fancy red skis. All right, we got the person standing on them like this. All right, standing at the top of the thing, top of the hill. There's some ski poles. There we go, something like this. And we'll have an unfortunate friend on their way down. Maybe not the best skier in the world. Maybe something like this. All right. There we go. Oh, we need some ski poles as well. Not doing them much good right now. Okay. So they're zooming down the hill. All right. Perfect. Okay. So outside, wintertime, it's cold. Let's say it is minus something degrees. We're not going to quite sure what it is. We're going to find out what it is. So it's something minus 3 Celsius. But when this person's going down, they are yelling at 4,200 hertz. And this person over here hears this person over here. Well, they're going further away. They're going down the hill, so they should hear a lower frequency. They hear 4,000 hertz. And we're going to use this information to see if we can find out the temperature. So what we're going to do is we're going to take our Doppler stuff we've done and combine it with our speed of sound stuff. So first of all, let's just worry about the Doppler stuff if we can. And with this person going like 15, let's do that, 15.3 meters per second. Okay, something like that. Okay, So we got a little bunch, we got the frequencies. Let's see if we can work with our Doppler shift first. So for Doppler shift, frequency prime, frequency 1, they're going further away, so we'd want to subtract V over Vs. And Vs is what we'd be looking for in this case. We got everything else. So, basic algebra, you'd want to, divide out the frequencies, 1 minus V over Vs. You'd want to subtract 1 and all that kind of stuff. But let's sort of put the values here for a little bit. So frequency primed, of course, the primed one is the one you actually hear. So that's 4,000 divided by the source, which is 4,200, is going to equal to 1 minus V, which is 15.3, divided by the speed of sound. And of course, the speed of sound is what we're looking for. So divide this out, subtract 1, and then just do a little bit of cross multiplying, and you can get the speed of sound. And that'll give us around 321.3 meters per second. Okay, now I have my speed of sound. I can use that to find out my air temperature. If I go back to my air temperature formula, speed of sound is 331.5 plus 0.6 T. Well, I've got my speed. I can put it right there. So I can take that, I can subtract the 331.5 from it to find out how much the speed has changed, and then divide that by that 0.6, and I can get a temperature of around negative 17 degrees Celsius. So there we go. So we'll Doppler shift and a little speed of sound sort of mixed together a little bit. Okay, well, let's try another question where the two are sort of put together. All right, so here we got a guy in some water, and they got a shark coming at him a little bit here. Okay, so let's say the shark is coming in at, let's go with 8 meters per second. Okay, you've got the poor guy screaming his head off, and let's say he is screaming at 5,280 hertz. Okay, and let's, of course, it's it's nice water, nice beach. Let's say it's 36 degrees Celsius outside. So what frequency does the shark here? Okay, well, first of all, we've sort of got the temperature there. I'm going to find my speed of sound. So my speed of sound would be 331.5 plus 0.6 T. So I've got that point. I've got 36. That's no problem. I got 36. Multiply that by the 0.6, and then I'll add the 331.5 to it and get my speed of sound. And I get around 353.1 meters per second. Okay, so there's my speed of sound. Okay, well, now I can do my Doppler shift part. So if I do my Doppler shift, frequency primed is frequency 1 V over Vs. Okay, add or subtract. Well, they're getting closer together, so the frequency is going to go higher, so I'm going to add the two together. So let's see, my original frequency is that right there. I know the V, shark is coming in at 8, and I found my speed of sound right there, so I just have to put the values in and punch out the value. And get around 5,400 hertz is what the poor shark is listening to as the guy screams. Okay, all right, let's try another question. Okay, so let's try this one. We got two guys out on their snowmobiles, and let's say, we'll do some temperature again. So let's say it's minus 10 degrees Celsius, not so cold. We got them cruising along. This guy's just sort of puttering along. He's coming along at, say, 12 meters per second. And this guy here, he's going way fast. He's just flying off the back of this thing, snow flying all over the place. Okay, and he's whipping out there. Let's say he's going 26 meters per second, so going like crazy. So let's say this one over here, this snowmobile over here, of course, is giving off sound and stuff like that. Let's say the sound of the engine is 1,800 hertz. And let's see what frequency this guy over here actually hears from the snowmobile in front of him. Okay, so let's see if we can figure this out. All right, once again, you got the temperature thing. So let's just find the speed of sound. Let's start that. So 331.5 plus 0.6 T. I know it's a negative 10, and so it's going to drop a little bit. So of course, 10 times 0.6 is 6. So I just got to subtract 6 from this. So it'll be 325.5 meters per second. There's my speed of sound. Okay, So now let's find the frequency. Okay, so frequency primed, and that's what I'm looking for, is frequency 1 V over Vs. All right, there we go. Okay, so first of all, add or subtract. Well, are they getting closer together or farther apart? Well, the guy in the back's only going 12. The guy in front's going 26. So they're getting farther apart. So he's going to hear a lower frequency, so I am going to subtract that. Okay, so now let's piece things together. Now, this we're going to be a little bit careful about something. We found the speed of sound, that's no problem. That's the 325.5. But this we're going to be careful with this, because that speed isn't just any speed. It's not the 12, it's not the 26. This is the relative speed. So a little different than the other ones, because the other ones we tried, everything, one of them's always been at rest. Well, that's actually the relative speed. If they were both traveling at 12, there'd be no change in frequency. If they're both moving at 26, no change in frequency. It's the relative speed between the two. This guy's going at 12. This guy's going at 26. The guy in front is moving away at a relative speed of 14 meters per second. That's how much faster he's going. That's what he's pulling away with. If they were actually coming together, the relative speed would actually be 38. They'd actually be coming together, and we'd actually add the speeds. So you got to be careful with that V. If one of the things isn't at rest, you got to make sure you have used the relative speed between the two. So I'm going to use the 14 there, not the 12, not the 26. I want to use the 14. Okay? So now that I take care of that, I've got my initial frequency of 18. I've got the 1. I'm going to use the minus because they're separating. Relative speed of 14. Speed of sound I had was 325.5. And we'll just put them together and get the frequency the guy riding the green snowmobile will actually hear. All right, so he should hear about 1,723 hertz. So that is the frequency the guy in the green snowmobile should actually hear. Okay, so this is a little more practice with the basic expression for speed of sound, which is basically a y equals mx plus b linear expression, like from grade 9-10 math. And then how we can alter the speed of sound by a certain percentage using the Doppler shift expression, which you guys first learned about in grade 9 science. And you can actually do the same Doppler shift equation with what you guys took in grade 9 with light. The only difference is you just switch that speed of sound for the speed of light, and you can do the exact same type of calculation. Okay, but that's a little more practice using sound calculations.